Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the starting material and first reaction. 2,4-hexadiene is HCCCCCH2CH3. Wait, 2,4-hexadiene is CH3CCCCCH3, hex 2,4 DNA. Formula C6H6 confirms this, 6 carbons, 2 triple bonds 6H. Moving on to the next step. Reaction with Li in NH3, Lic. This is a dissolving metal, Birch type, reduction of an alkyne, specifically a partial reduction. 1 equivalent of Li NH3 reduces 1 triple bond via transaddition of H to giving a transalkene. With 2,4-hexadiene, internal DNA, Li NH3 reduces one of the triple bonds to give a trans, E, anion, CH3, CH is equal to CHCCCH3, I, E, hex 3N1 Yane or more precisely, E, hex 2N4 Yane. The dissolving metal reduction of internal alkynes gives transalkenes. So the product is E, CH3, CCCH is equal to CH, CH3, I, E, hex 4N2 Yane, CH3, CCCH is equal to CH, CH3. Actually, with a symmetric DNA CH3CCCCCH3, Li NH3 reduces 1 triple bond to give E, CH3CCCH is equal to CHCH3. Moving on to the next step. Treat with 1 equivalent Cl2 in CCl4. Cl2 in CCl4 adds electrophilically across a double or triple bond. The molecule has both a triple bond, C2C3, and a double bond, C4 is equal to C5, trans. With 1 equivalent Cl2. Addition to the double bond, trans anti-addition of Cl to 2, CH is equal to CH gives the anti-addition product. For E, alkene, anti-addition gives the RS is equal to meso or trio product, specifically the 3R, 4S plus 3S, 4R pair for the dichloro product or a specific diastereomer. Addition to the triple bond, anti-addition gives A, E, 1,2-dichloroquine, transvinyl dichloride. And for the final step, identify constitutional isomers from products. The two possible constitutional isomers arise from Cl2 adding to either the C is equal to C double bond or the CC triple bond of E, CH3CCCH is equal to CHCH3. Addition to C is equal to C, positions 4, 5 gives CH3CCCHClCHClCH3 4, 5 dichlorohex 2 Yane. But this is a 1,2-dichloro compound on the former double bond portion. Addition to CC, positions 2, 3 gives CH3CCl is equal to CClCCH is equal to CHCH3, E or Z, 3, 4 dichlorohex 3N. Wait, let me re-examine the structures in the image more carefully in terms of carbon skeleton and Cl positions for a 6-carbon chain with 1 double bond and 2 Cl atoms. Structure: IgM dichloride at 1 carbon adjacent to a double bond. This would be a 1,1 addition or rearrangement, not typical. Structure: 3-vicinal dichloride with Cl on C3 and C4 with double bond at C1, C2 or C2, C3 region. Given the answer is D, I and 3. These correspond to the two constitutional isomers, one from Cl2 addition to the triple bond giving a vinylidene dichloride type, JEM, product, I, and one from Cl2 addition to the double bond, 3, or both from addition at different sites giving different connectivity. The key concept E, hex 2N4 Yane reacts with 1,8Cl2 at either the double bond or the triple bond, giving to different constitutional isomers. Structure I, Gemdichlorovinyl type from triple bond addition giving CCl2 is equal to and structure 3. Vinyl dichloro from double bond addition are the two possible constitutional isomers, which matches answer D. Therefore, the correct answer is D. Therefore, the correct answer is option D.